Hello everyone, I am Chakib Mohssine from University Mohammed 5 of Rabat of ENSAM Rabat. Today I will present you my work about the participation in microgrid frequency regulation of variable speed wind generator based on DFIG by using ADRC control method. The plan of this presentation is the introduction, problematic and summary, the DFIG based wind turbine modeling, then the active disturbance rejection control presentation, then the primary frequency control, then we have the integration of the wind turbine in microgrid in the AGC control, then the simulation result in discussion, and finally the conclusion. In recent years, there has been an evolution in the electricity production based in wind energy compared to other energy sources. In following the strong penetration of the wind energy into the electrical grids, the wind turbine generator must participate in frequency stabilization in the event of an imbalance between the electrical energy produced and that consumed. So the problematic of this work is the lack of the frequency stability in the power system due to the imbalance between supply and demand of electricity. Also, the variable speed wind turbines are insensitive to frequency variation due to their power converters. Also, the increasing penetration of wind power plants in the electrical grid will result in deteriorated frequency regulation performance due to the reduced of the overall system inertia. This work aims to make the DFIG based variable speed wind turbines to participate in the primary frequency control in the microgrid through the active power control of the DFIG by using inertia control and droop control. Also, the control of the active and reactive power of the DFIG by using the ADRC control, and we compare it with the classical PE controller. Finally, the application of the AGC technique to the microgrid in order to restore frequency to its nominal value by using a secondary control loop. The modeling of the system wind turbine is as below. Is composed of the wind turbine, the power converter, and the rotor side converter. When we apply the frequency regulation to the rotor side converter control. The principle of the IDRC is to include the extended state observer, which ensures the function of the estimating and rejecting all disturbance can affect the system. Two techniques of the primary frequency control are adopted: the inertial control, which uses the kinetic energy stored in the rotating components of the electrical grid, and the droop control, which uses the reserve power obtained by moving the wind turbine from the operating point to the suboptimal operating point. The AGC control or secondary control loop is based on an integral controller allowing to adjust the output power of several generators in response to change in the load in order to restore frequency to its nominal value. So our microgrid studied is composed of a thermal generator and a wind turbine system. The simulations are carried out by using 5 scenarios. The scenario 1 is only the thermal generator participates in the frequency control. Scenario 2, the activation of inertial shaper of wind turbine. The scenario 3, the activation of the droop controller of wind turbine. The scenario 4, the application of the both control technique, inertia and droop controller. The scenario 5, the application of the AGC control at t equal 30 seconds. The simulation results show that the participation of the wind turbine in frequency control give a good improvement in frequency response In this table summarizes the results of the frequency performance response for the 5 scenario. Also, the application of the EGC permits frequency to return to its nominal value. So the ADRC controller allow the defect to follow the power reference as shown in the simulation results, and it gives the good performance and the high performance compared to the classical PE. Finally, we conclude that the IDRC controller is an efficient and good approach for controlling the DFIG. The inertia control of wind turbine provide a short-term active power support in order to avoid the rapid drop in frequency. Also, the drop controller intervenes to allow the wind turbine to provide an active power support over an extended period of time. Finally, the secondary frequency control loop is applied after the stabilization of the frequency by the primary control loop. It allows the frequency to be restored to its nominal value. Thank you for your attention.